Hi guys, welcome back. This is the first example for indeterminate structure. As you can see, in this truss we have internally indeterminate, but externally it's determinate because this is only a roller and this is only a hinge. So if by method of joint or method of section for these to find the forces in the members, we cannot find it because number of the unknowns will be greater than number of equations that we have. So this procedure is very easy. You can find it easily. You just have to follow these steps. So first I'm gonna separate the first panel and find the shear for it, so I can know the direction of these two, because these are very important to find the correct direction of them. So for the shear, it's gonna be acting downward, as you can see in here. Equilibrium equation, summation of y equals to 0 minus 1.8 plus 3.6 minus v equals to 0. So v is correctly acting downward. So these both two will be acting downward. FB is in tension and AE is in compression. So summation of y for this whole panel with these two diagonals, minus 1.8 plus 3.6 minus 2f, they're equal in magnitude. 3 over 5 equals to 0. F is equal to 1.8, so each one of these is 1.8. This is in tension, this is in compression. Summation moment about A to find the FE. Summation moment about A equals to 0. FE times 1.8, this is the distance, minus 1.8, 4 over 5 times 1.8. I only took this one because this goes through the point that we're taking moment about. So this is in compression. These both two are equal in magnitude because there's no any external horizontal load, so they're equal. FE is equal to AB, which is 1.2. This is in compression, this is in tension. And then I'll take the method of joint to find AF. Where's AF? I'll show it to you. Here's AF, this member. So I have these forces acting on that joint. So summation moment, the summation Fy equals to 0. I find AF, which is compression, 2.7. I finished for this panel. The second panel, the same procedure. I find the shear, so I can know the direction of these two. As you can see, it's acting downward, so these two are acting downward too. For DB, it's in tension. This one is in compression. Summation of y for this whole panel to find the magnitude of these diagonal members is 2f times 3 over 5, the slope, minus 2.7, this one, and plus 4.5. This is in tension, this is in compression, 1.5, 1.5. Summation moment about C to find ED. The same procedure. So ED times 1.8, the distance, times 1.5, this one, because this goes through the point of moment, times the slope times the distance. So ED is equal to BC, which is 1.2. And then I'll take the method of joint again to find BE. Where is BE? In the main structure, here is BE. Summation of y. Oh, we found it. It's in compression. Then joint C. Where is joint C? Let's see it. Here is joint C to find CD. By summation of y. So we have minus CD, minus this force times the slope, and this one, and that's it. That's how you find the force in each member of the truss. If it was indeterminate, it's the same procedure for every truss. But for example, if we had a larger truss for more than 2 panels, as I'll draw it here. If I take this panel and then this one, I will draw all of it. For example, This is the third panel, and this is the first one. So I have to take it all of it. If there was any external load, any horizontally, I'll draw it, all of it. That's the only note I have for you. It's very easy. And like and subscribe. Tell your friends about it. And if you have any question, comment down below. And thank you very much. Goodbye.